Okay, hi guys, welcome to this video lecture. This is our Flipped Classroom 3. On previous Flipped Classroom, we work with data that are now built on groups, but now we're going to work with data that actually they are formed in groups. Remember, we have our classes, right? So we're going to work with the variance, standard deviation, and theorem of Chevishev. Okay, so remember that variance is a measure for the dispersion of our data, right? So it tells how they must vary between each other, right? So this is the meaning of variance. Now in this slide, I show you the formula for variance. In this case, we have the variance using this symbol to the square equals to the summatory. Remember that it's very important, the summatory. And F, it is the frequency of the class. Remember, the repetitions of the times they repeat the data. And here we have where x or I is the middle point of the class. So if you remember, if we have our classes, so we need to get the middle point of each class, right? That's the meaning of this x or I. And x is the mean of the sample, the mean of the entire sample, and of course n is the number of the observations we have in our sample. Perfect. Now continue with the standard deviation. You will see that it's pretty much the same formula, but the difference here is that here the symbol it no longer has the square, right? So here we're just adding to the same formula as the square root. So we still have the same frequency, we still have the middle point, the media, the mean of the sample, and the number of observations we have, right? So remember, just the difference is the adding of the square root. Perfect. Now here we're going to talk about something very interesting, that is the Chevishev theorem. So in the beginning, a Russian mathematician intended to prove that indeed the standard deviation was the measure for the dispersion of the data. Now, how did he do that? Okay, so we have here a formula that is the percent equals 1 minus 1 divided k squared. But what's the meaning of that? What's the meaning of that percent? Okay, suppose here I'm going to show you this graph. This graph is showing you a curve. There is a bell, a distribution of a bell, and you will see that inside this bell, inside this curve, you see here, you will find all your data. Yes, and you see that if I put here my finger, yes, here is the 0. So we're talking here the mean, right? So as we increase the distance from the 0, from the mean, you will find more data, right? So if we are near to this mean, you will find just not all the complete data. So for example, here we will only find the 68% of your data. So as you increase the distance, you will find the 95% until you find almost the 100%. So in this case, the 99.7%. So returning to the formula here. So percent, where is the meaning of this percent? This percent means just the probability you have to find a certain random variable inside this space, inside this curve, just the probability. So in this case, the k means the deviation, right? The deviation you have. So if you do this calculation, you will get a point something, and it will turn to percent, and that will mean the probability you have to find the value inside this group of data, inside this curve, right? So for now, it's all. Right now we're going to pass with just a couple of exercises. So I will leave you with teacher Jorge. So have a good day, guys. Bye.
Hi guys, continuing with this topic, we have to cover some exercises, some examples, so we have to review it, okay? The first one is the variance. It says, an ice cream store reports the next profits on a regular week in the next table, determines the variance. The only thing we have is the classes and obviously the absolute frequency per each class. Now, remember, we have to cover them all using the formula we saw and also fill in this table. Let me just erase this and also this. Now, the most important part is to identify the low limit and the up limit. Obviously, the absolute frequency that you have here per class, and review the formula. For the variance says that you have to subtract the class mark minus the average or mean, make it to the square, then multiply it by the absolute frequency, make a general addition, and then divide it by the total observations minus 1. And I know it looks and sounds complicated, so let's make it one step at a time. First of all, we need to get the average or mean. How do we do it? We have to multiply the class mark times the absolute frequency. But how do we calculate the class mark? Remember, it's an average between the low limit and the up limit. So you have to add the low limit plus the up limit and divide it by 2. Then make it for each class. Now you have to multiply the absolute frequency times the class mark and make it for the entire classes. Now it says here that we have to make a total addition, so we have to add this column right here and then divide it over the observation, the total observations, and this is the value for the absolute frequency as a total addition. So as we did previously, we have to make it in this case. So the average will be finally this value over this, and it's 23.06. Now we have to subtract the class mark minus the average as a constant. So the first value is 16.5 minus this average. And don't worry about this sign. Why? Because it says here you have to make it to the square. So it means that the negative sign is going to get away. To make it as a constant, here we can add it, these signs, and we get it. So we copy the entire formula, and you can confirm that, for example, this class mark is minus the same average, and this class mark is also minus the same average. Good. Now you have to make it to the square, so this value is times this value. Copy the entire formula, and then finally this value times the absolute frequency. So we have to multiply it by this. Good. And the formula says that we have to make a general addition. So, as we did before, a general addition of this, and that's the entire value. And be careful, because it says here that we have to make it the total observations but minus 1. So it's not 80. It will be this minus 1, so it's 79, obviously. Finally, the variance will be equal this value over this. And the result, as you can see, is 19.39. Good. Now, as Isa explained, the standard deviation is only the root over this entire value, because this standard deviation represents only just from the 0 to the left or from the 0 to the right. Make it positive or negative. So you have to make it like the root of this value, and the total is 4.4. Now, continuing with the topic, we have to cover one last example of this Chevishev theorem. The example is like this. The arithmetic mean of the monthly sum of the contributions to a pension is 51.54 pesos, with a standard deviation of 7.51. At least, which percent of the contributions are found in more or less 3.5 standard deviations? So we have to cover this k value with 3.5. So as you can see, 3.5, you have to make it to the square, then this value is divided over 1, then 1 minus this fraction, and the result is 0.92. Finally, is 92%. So you have a 92% of chances to identify that value under the bell that is explained previously. So by so far, this is all. Take care, and we will see you soon in class.